My name's Ryan Underwood. I'm a junior here, and I'm in Dr. Tian's heat transfer class, heat transfer 1. We actually had, I believe, 6 maybe labs, each with a different goal in mind. Most of them were the effects of heat transfer on an active heat sink, calculating the heat transfer rate, the effectiveness of it, and things along those lines. So every other week we would go into the lab, perform an experiment, like calculating the effectiveness of a fin, and then afterward doing a small write-up of the results and interpreting the results.
My name is Joseph English. I am in Heat Transfer 1, Part 1, and I'm a mechanical engineering student at UCF. This class was unique, especially because we did have a lab that was a side of the class, which I found to be very helpful and very hands-on, where you learn theory in class, but you actually get to work with tools and experience what you're learning in a different way in the lab. We're going to put a thermocouple very close to the surface, and then we're going to do a thermocouple into the middle of the potato. This temperature will be higher initially. This will be the lower in the center, but it's going to warm up over time, and that's what we're going to be testing.
My name is Matthew Julian. I am in Dr. Tian's heat transfer class, and this semester we have been working on an active heat sink project. Initially, we started with a bare heat sink and attached thermocouples to it. We started off with verifying Newton's law of cooling, and towards the end of the semester, we have actually used a blower to verify the heat transfer coefficient, or to find the heat transfer coefficient when you have forced convection.
Yeah, this is definitely far better than all my other classes, just because it's different, because you're not sitting there passively receiving information. A lot of times with engineering, you just receive numbers and equations, and these numbers and equations, they don't mean anything to you until you put in a real-world application.
The analogy I would make is you could sit here and study the theory behind an automobile and how it works for a year or 4 years and never turn a wrench, and then go out into a garage and say, here it is, fix it. And there's just no way you're going to fix it. I mean, even though you have the theory, you really have to go out, you have to get dirty, you have to turn wrenches to learn how to work on a car. And so I think that's sort of like, I think for this class in particular, that's what we're doing, is we're not only learning the theory, but we're turning our wrenches and we're learning how to work the tools of the class.
What Dr. Tian's doing with her lab is actually giving us more experience in, like industry and how to actually acquire data and information in a lab setting.
And here you can see too the current, this is the exterior temperature of the potato and that is the interior. Eventually they should be in equilibrium. So that's essentially what we're looking at. Until you really touch it, until you really put your hands on it and play with it and experiment, you don't know if 40,000 watts or 3,000 watts. You don't know what the difference is, and you don't know what really you're looking for until you enter into the lab and have experience with it.
You actually have to interpret and understand what you're getting and why you're getting what you're getting, and to write about it and then submit that, rather than just submitting a number, which is what all physics labs are about. So that doesn't really prepare you for, how a lab works. A lab works by understanding your procedure, what you need, how to go about setting up your process, and then performing your experiment, analyzing your results, figuring out if there's any errors in your experiment, and then interpreting your results. This is found in research. A lot of research professors know this, that's how it works, and industry knows it too.
So I think this semester, having the opportunity to work in this lab and work on this active heat sink project in a group, I think that it was just a great opportunity. It gave us an opportunity to get hands-on experience and hands-on learning of the stuff we're learning in class. And I really feel like it really reinforced these things that we learn in class, and it's a big difference of learning something out of a textbook than it is to get that hands-on experience and actually taking this data and getting these results from it and seeing this firsthand.